Hi, my name is Michał Ambroziewicz, obviously. Today we are going to talk about Kafka, but first let me introduce myself. I am a solution architect at NetSprint. We are an online data-driven marketing company, a house of data, if you will. If you want contextual advertising, behavioral targeting, behavioral profiling, you come to us. So, today we are going to talk about Kafka, but it won't be an ordinary tool presentation. Today we are going to dive deep within the pathology of code. So, before we start, a little disclaimer is in order. This talk is not intended to harm anybody or cast anybody in bad light. So, before we are going to start, some precautions are in order. We are going to work with serious pathogens, you know. You folks know Monty Python? Well, let's do it Monty Python style. Gloves, glasses, mustache. I'm going to operate. Specimen number 1, Hotspots. Let's imagine a brand new Kafka server. Brand new Kafka cluster. Everything configured A-OK. Nothing's wrong with it whatsoever. How can we mess with it with a single class? As you can see, it's just a couple of lines of code. As you can also see, there's a question mark at the end. What can we put in there to weaponize it? Null? Nope. Too mainstream. Nobody falls for it anymore. But a string literal is just good. But let's make it a little bit more sophisticated. Let's say we have an application that serves for about 3 clients, from which one generates about 50% of the traffic. You're getting the idea what it might be? A customer ID, company ID. So, why? The question is why. It's all because of partition assignment. When you pass a null, a random partition number is generated for each and every message, and this message is sent to a random partition. But when you pass a value, a murmur algorithm kicks in, and it calculates a value partition number for you. So, when you pass each and every value the same each time, every time you get the same partition, thus preventing the load balancing and creating a hotspot. But it can get even worse. Your messages, after all, get consumed. Each consumer stores its offset within Kafka. Well, actually, it's default behavior. You can store it in Zookeeper, but usually you do it in Kafka. Sorry, not this slide. Now, how can we spot this kind of problems? This kind of problems, well, we have to look for the cluster imbalance. We can do so by examining partition metrics. Especially, we should look for incoming and outgoing traffic imbalances, and we should also mind replication traffic. Why? You will see in a moment. How can we avoid that kind of problems? Of course, we can use high cardinality IDs. If we don't care about IDs, we can about keys, we can use nulls or randoms IDs. Do not use constants and low cardinality IDs, and by low cardinality I mean cardinality that is lower than partition count. But as I said before, it can get even worse. Your messages, after all, gets consumed. Those offsets are stored in consumer offsets topic, and it has a unique key structure. It consists of consumer group name, topic name, and the partition number. Can you see the problem? Yes, the partition number. If you have a hotspot in your topic, it will get reflected in commit hotspots. But the consumer offsets hotspot, consumer offsets topic, is unique not only because of its key structure, but also because it's replicated times 3. So each of your hotspot will be replicated. So far, not so bad, yeah? But you can make it even more vicious. How? By committing irresponsibly. Depending on your use case, if you actually need to commit each and every message, that's called exactly once semantics. But if you do it just because you can, it's called overcommit, and it ends up like that. How does it look in the wild? Well, here we have a Grafana plot spanning about 20 hours. It's offsets commit. As you can see, there's a rather big imbalance between the nodes. The most loaded is about 2 orders of magnitude higher than the least loaded. As you can also see, there's a drop in the traffic. That's the moment when the operator realized the situation, found out who was responsible, and shut down the application. As you can also see, if you look closely, the cluster, after all, is still a little bit out of balance. It might need manual rebalancing. And here you see the replication traffic I was speaking about. If you look closely, the outgoing traffic, which is red, is about 3 times larger than the incoming traffic, green, for the node that is most loaded. And here is what saved us. An alarm was tripped that indicated that we have exceeded 10% of CPU I/O weights, and then the operator started to act. What was the result of the incident? Well, fortunately, not catastrophic. As you can see, one of the node dropped significantly with its average idle. But if you are familiar with Kafka, you can see that this value is not disastrous yet. But note that we have had an incident, a similar incident, that led to catastrophic cluster failure. Combined with a bug in Kafka, if I recall correctly, it was 0.9.5. It caused one of the nodes, which was the hotspot, to fail, but not to drop out of the cluster. So part of the partitions were still assigned to that node, but it couldn't be processed. The node didn't accept any traffic, but it still responded to heartbeat. So some data was lost until the problem was found out and fixed. So mind those kind of problems. Here's a quick tip how to find a culprit. You can always use console consumer to pick on the consumer offsets topic. As you can see, you need to use offset message formatter, as this topic is binary encoded. Note also that you will need to configure your consumer to allow you to access special topics. Just run this command and run some statistics on it. You will find which of the consumers commits the most. The later one, if run, will allow you to find out which of the partition is out of balance. Just run it a couple of times, then make a differential, and you will have a clear picture. So let's recap the first specimen. First of all, mind your keys. Use only high cardinality or don't use them at all. Monitor your cluster balance. You are looking not only for spikes, but also for any kind of flat lines. Check whether your node didn't go silent all of a sudden. And monitor your producers and consumers, not only in terms of their performance, but also check if your consumers don't lag. Next specimen, client crashes and bad exception handling. Here we can see what we can find in almost every tutorial or example on the web. No exception handling mentioned whatsoever. If you are lucky, you will get one with catch-all clause. If you look at the Java API for Kafka client, it's almost the same picture. No checked exception forcing you to handle anything. So what would a rookie developer do? Well, exactly what you see on the screen. Then pack his gear, go home, his work is done here. But when we look at Javadoc, it's an entirely different picture. If each of commonly used methods throws a multitude of runtime exceptions. They are in certain categories. One of them is retriable exception. Those should be at least logged, well, caught, logged, and retried. If you have even rudimentary log monitoring, it should be enough to make the operator aware of the situation if it persists. The other might require you to recreate a client, to fail your application health status, to restart it, and so on. It depends on your use case. So now Hazmat suit time on. We are about to work with the most vicious specimen of all in this talk. Let me tell you a story. There were two developers. Let's call them Nick and Tim. Nick found out that they had some timeout exceptions in their applications. So he consulted Tim, who was older and more experienced. And Tim told him, don't mind it. Just push the timeout and it will be fine. So he did. It didn't help. He came back to Tim and said, well, it didn't help. Push it a bit farther. So he did. This time it helped. The exceptions vanished, but so did the consumers. The next day, a product owner, mad as hell, storms into the office and yells, why the hell all of my campaigns are stopped today? Why didn't they start? Well, what happened? To understand this issue, we have to first understand the mechanism of Kafka called heartbeat. Each time you call a poll, a heartbeat is sent to a broker. If you fail to send this heartbeat within pre-configured interval, the broker considers this client dead and rotates its partitions to other alive clients. By pushing this timeout too much, they exceeded the heartbeat, and each of the clients died without a good reason, actually. So, what can we do to avoid this kind of stunts? Of course, handle all of your retriable exception. This time, this example is actually so bad because the underlying problem probably wasn't even connected to the timeout exceptions that were in the logs. Actually, the poll should return no records not throw exception if there is no data available. You should, of course, properly handle all of the others exceptions and be prepared to recreate your client if necessary. Also, keep your eyes open for this kind of things during code review. Especially your younger colleagues might be tempted to just copy and paste some kind of example from Stack Overflow or any other place in the web and thus create some kind of problem. And most of all, monitor your clients. While we're at the monitoring, let's move to another specimen. This time, the specimen is lack of specimen. Some might say that monitoring is expensive. We cannot afford it. We don't have time for monitoring. We have to do the features for the business. Well, let me put it other way. Monitoring is cheap. Lack of monitoring is expensive. It's expensive compared to your application downtime. It's expensive compared to lost revenue. It's compared to your clients fleeing from you to your competition. What can go wrong without monitoring? Well, considering Kafka, well, just about everything. You can have hardware problems, network outages. You can have all kinds of performance problems, and they may cause service degradation. You might not even notice it. The clients will tell you. And of course, there is lag and data loss that it can lead to if it amounts to a certain value. So let me give you a tip. Monitoring on a chip. You don't need commercial Confluent Platform license to do that. Everything you need is either bounded with Kafka or just open source. Kafka exposes its metrics through JMX bins. So you have a data source. Then you will need something to ingest it, store it, and present it. And for that, Telegraph, InfluxDB, and Grafana is just perfect. It's all open source. You will probably need to write some custom scripts to calculate your topic's lag or to extract data from JMX, but that's not a rocket science. It's, well, a couple of man days at most. There is also a question of log monitoring that we cannot forget about. If you cannot afford, let's say, an Elasticsearch cluster with Kibana and so on, you can always use more rudimentary solution. Just create a custom log4j-appender that will collect your logs, search for, let's say, exception or other items that interest you, and output it as a metric file that will be later ingested by the Telegraph. Let's move to specimen number 4, cleanup policies. Well, there are 2 cleanup policies, and you can go wrong actually with each of them. First of all, most problems arise when you don't know which policy you are using at the moment for your topic and how it is configured. With Compact, the problem is that it works by leaving only the newest value for a given key. So if you don't know that you have Compact policy, you pour your data in and you, let's say, run your KSQL query, you might be in for a big surprise when the results come back. With delete, there's another problem. Actually, it's capacity planning. There is a configuration property, partition max bytes. So some of you might be tempted to calculate your capacity by taking this value times your partition number, times your replication factor, times your number of topics, and that's your planned capacity. Well, it's a lower bound only. Kafka is guaranteed to store at least that much data, so you might be again in for a big surprise. Let's move to another specimen, communication breakdown. Let me tell you another story. This one started when a new cluster was created. It was for sizing purposes, technology assessment, and so on. Developers adopted it, so it was decided that it's good. New nodes should be added. It became productional. But after the nodes were added, the developers actually acknowledged operator's message about new nodes, but didn't update the Bootstrap server list. Time passed. The developer team rotated, and after some time, it was decided that the oldest 3 nodes should be decommissioned. Again, the developer teams were informed, but the new team members thought they were safe. After all, it's only 3 nodes out of, well, 7 actually, so they should be all okay. Well, they weren't. Actually, a couple of days after the commissioning the nodes 1, 2, and 3, after a restart, the application failed to boot. So, as a development team, always be sure you have current Bootstrap server list. As an operator, make sure that that developers acknowledge actually updating the Bootstrap server list, not receiving the message. Now for a couple of hints. A quickie. Don't be afraid of spinning disks. They are much cheaper per gigabyte. Kafka handles them surprisingly well and performant, and it saves you a lot of pain during sizing. After all, they come in rather big sizes. Next, you should separate your production and staging environments. That's a bit obvious, isn't it? Well, actually, some of us might be tempted to put just a few messages from the staging up just to make sure it works through the production cluster. Well, resist. It's a camel's nose in your tent, and the rest of the camel is soon to follow. Let's say in form of a rookie who takes your config and decides to run a load test on it. Next hint is about data loss. Some of you might be fine with moderate data loss, let's say at most once delivery. But if you are not, make sure you use producer acknowledgements callbacks. The producer methods are asynchronous. The fact that it exits without throwing an exception doesn't mean that your message actually got delivered. Don't be afraid of embedded Kafka in your tests. I'm not saying you should put embedded Kafka in all of your tests, because it will, of course, cripple your performance, but consider using embedded Kafka at least in your integration tests, and it can save you a lot of pain later. If you are using some kind of sophisticated framework like Spring or Vertex, consider using its abstraction over Kafka client. It is usually a good fit for you. Sometimes it just needs a bit of tuning, and it saves you from reinventing fire and wheel all over again. Let me end with 2 quotes. First of all, know yourself and know your enemy. There are a lot of good materials on Kafka on the web, including this book. Well, it's actually almost free. You have to trade your email address to get it. But it's still cheap. Use it. Make sure you learn about Kafka as much as you can before you go into production, especially if you are the most experienced developer or team leader on your team. If you make a mistake, it's not a failure yet. Yes, I let this sink in. It's not a failure yet. Failure is when you ignore it, or worse, cover it up, and somebody else on your team or yourself will repeat it. Don't use it as an excuse for a witch hunt. Make it a lesson learned. Make it something positive. That's all I have for today. Thank you very much.